All right, so let's try an example here. This is number 1. We'll do that one first. So the very first one here is a child pulls a 6.5 kilogram sled with a net force of 14.2 newtons. Determine the sled's rate of acceleration. So before we even start this question, what we need to do is look back at what our formula is. And for our formula, it is F is equal to ma. So that is, I guess, the formula that we will use. So we have got force, we've got mass, and we've got acceleration. And if it's in the case of acceleration being what we need to find, then that is force divided by mass. All right, so if we read through this question, it says a child pulls a 6.5 kilogram sled. 6.5 kilograms is a mass with a net force of 14.2 newtons. So our force is 14.2 newtons. Determine the sled's rate of acceleration. So our acceleration, we don't know what that is, and that's what we need to find. So we're going to use this formula, A is equal to F divided by M, and calculate that. So our force divided by, not N, sorry. So our force here is 14.2, and that's in newtons, divided by our mass, which is 6.5 kilograms. So if we put that into our calculator, 14.2 divided by 6.5, that'll give us 2.18462. And that is an acceleration, so that's in meters. Oh, I'm picking the wrong one. Meters per second squared. For this one, if we're looking back at our significant digits, back to our question, there's 2 here and 3 here, so we want to round our answer to 2 significant digits. So we're going to round this to 2.2 meters per second squared. Okay, so that would be our final answer for that one. Trying out number 2. Maybe I can put that right here. Maybe. Perfect. So we're going to do number 2. So number 2 says a net force. Well, before we even read the question, I'm going to set up my little table and start reading. So it says a net force of 16 newtons. So our force is 16. Don't know why my Apple Pencil is not liking me today. Is applied to a soccer ball with a mass of 0.25 kilograms. So that would be our mass is going to go here. Calculate the ball's rate of acceleration. So again, we're figuring out acceleration. So our formula is acceleration is equal to force divided by mass, I believe. Just double check back up here. Yes. So if we're calculating that, we want to plug in our information. We got our force is 16 newtons. Divided by our mass, which is 0.25 kilograms. If we do that, 16 divided by 0.25, that gives us 64. And that's an acceleration, so it's in meters per second squared. Our question has 2 significant digits. This also has 2, so we're good. That's the answer. Okay. Let's try number 3. Number 3 says, what net force would be required to cause 0.040 kilogram object to accelerate. Oops, what am I doing? .040 kilograms to accelerate at a rate of 2.50 meters per second squared. Okay, and then it's asking us what must be the mass of the object. Okay, no, that's not what the question is asking. Am I reading two different questions? I am. Wow. Let's start this over. I was mixing the two questions together. So the question's asking what net force would be required to cause a 0.040 kilogram object to accelerate to 100 meters per second squared. So we're using F is equal to MA, where we're just going to multiply these two numbers together. And when I multiply those together, I get 4. That's a force, so it should be in newtons. Okay. Notice that our question, there's like at least 2 significant digits here. So if we're doing significant digits, this answer should be 4.0. Okay. And then our final question, practice problem here. Let's try that one out. It says a net force of 5 newtons is applied to an object, causing it to accelerate 2.5 meters per second squared. That's where I got that last question. What must the mass be? So we're looking for mass. We don't know what that is. If we take the formula F is equal to MA, we're going to have to rearrange it so that we have mass by itself. So we want mass by itself, so we want to move the A to the other side. And to do that, we're just going to divide. So if we divide both sides by A, that'll get rid of it over there. So M is equal to F over A. Okay? So let's plug in our information. We got 5 newtons on the top, divided by our acceleration, which is 2.50 meters per second squared. Okay? And if we calculate that on our calculator, 5 divided by 2.5, I guess you're going to understand that's 2. So what should the mass be? What must the mass of the object be? Well, the mass of it is going to have to be 2. And the mass is always in kilograms unless otherwise stated. Okay, I'm putting 2 zeros there because we've got 3 and 3 for significant digits. All right, so that is those examples. Try some out for yourself on the topic 5 review, and we will continue this on later.